At the end of part 2, I thought it might be fun to change the size of the fox as he chases the hen. Here's the code where we left it. So let's go down to draw. And in here, let's see, I'm going to change the size of the fox because I'm going to be computing his radius now. So I'm going to change the radius that I use in this line to be lowercase fox r. By changing this from uppercase to lowercase, I'm referring to a completely new variable now. And in fact, if I try to run it, processing will complain. It says I don't know what lowercase fox r is. And that's fine because I'm going to make it right up here. So first I find the distance from the hen to the fox. And I'm going to say when the fox is nearby, he has a small radius. And when he's far away, he gets a big radius. So tell you what, let's just kind of go by the seat of our pants here. I'm going to map the value of d, the distance. Now I know that the smallest value that d can ever have is 0. That's when the fox and the hen are on top of each other. And I don't know how far the fox is going to get behind the hen. Let's say maybe 100 units. I'm guessing here. And I'll say that when the fox is right on top of the hen, he has a very tiny radius. Not quite 0, maybe just 1 unit. So it's just a tiny little dot. And when he's far away, when he's 100 units away, he has, let's say, 5 times the big fox radius. That's the radius I assigned him. So he's 5 times whatever that is when he's far away. Okay, let's run this and see how that goes. All right, he's right on top of the hen, so he's very small. And as the hen starts getting further away, he gets bigger. Whoa, 5 is probably way too big. Tell you what, let's clear the background. Okay, 5 is probably way too big. And maybe now I want to switch the order drawing the fox on top of the hen. Well, maybe if I don't make him quite so big. So tell you what, let's make it 3 times that. And now as I go, change the background. As I go faster, he gets faster. And as I go slower, he gets smaller. And I can do this kind of thing by jumping with my mouse, which is kind of cool. Let's see if I can kind of get a trail. This thin thing and then a blobby. All right, well, this is feeling pretty good to me. So I'll tell you what, I want to turn this on and off because maybe I don't want this all the time. So let's invent a key to turn that on and off. What haven't we used yet? How about R for radius scaling? So if key is R, then we'll call it change radius equals the opposite of change radius. Tell you what, change is such a generic word. Let's call that scale radius. So I'm going to copy and paste that. So now I have the Boolean declared. I need to give it an initial value. Let's say initially it's not true. We won't do it. So how do we make that work? So first I'll create foxr and make it equal to the radius. And then I'll say if scale radius, if we're doing this thing, then we'll do these 2 lines. I'll indent them. Now I don't need to declare foxr. So the first thing we do is we set foxr to the global. And then if we're scaling, well, we overwrite it with a new number. So let's go ahead and see if that works. I'll turn off the background clearing. Everything seems to be fine. I zip along fast and slow. And now I hit R. And the fox behaves. I hit R again. Fox doesn't do it. All right. Well, this is a pretty good program as far as I'm concerned. Let's turn this thing back on. So what? Let's clear the background and unclear it. And now I can draw some stuff. So there's plenty of room for experimentation now. But this is pretty much the fox and hen program the way I originally envisioned it. It's just kind of a fun little painting program. And you can take this in a million directions. But I hope by watching over my shoulder, you've seen how I build up these programs one step at a time. You deal with the errors along the way, and you just build it like you were building a cabinet. You stick in a piece of wood here, you add a drawer, you add another drawer, then you put the doorknobs on the drawers, and bit by bit, the program comes together.